Okay, so in this video we're going to look at the present value of an ordinary annuity. In the past you've looked at future values. This series of payments, what will the value be in the future? This time we're looking at the present value right now. This example is a good example of that. What amount must you invest today at 6% compounding annually so that you can withdraw $5,000 at the end of each year for the next 5 years? Really important that we draw these. We always start with a drawing. Okay, so 0, that's now. 1, 2. Let's go back. Sorry, try to get in the habit of doing things consistently. Let's put the years up the top. 1, 2, 3, 4, 5. Now let's look at those payments that are coming out. There's going to be a $5,000 payment here that you pull out, $5,000 payment here, $5,000 here, here, you get the idea, and here. Now we need to know the present value of each of those individual 5,000s. So just grab a color here. So that means we need to know the present value of this 5,000, the present value of this 5,000, of this one, you get the idea, and of this one. And we need to know the present value of each of those things. Now, let's find the present value of this 5,000. That's going to be 5,000 times 1 plus I to the power of -1. You'll remember to the power of -1 when we're going back in time with our present value and future value calculations. Now the present value of this 5,000 is going to be 5,000 times 1 plus I to the power of -2, because there are 2 periods between here and here. And you'll hopefully see a pattern forming. 1 plus I to the power of -3, 5,000, 1 plus I to the power of -4, 5,000, 1 plus I to the power of -5. Okay, so now we need to find the sum of these terms. And you'll remember the formula for the sum of a geometric progression. I'm going to use present value equals A to the R to the n minus 1 over R minus 1. And we have our nice little sum of a geometric sequence formula here. Now we need to find our first value. Now this is where things are going to get complicated. You're going to be tempted to think that the first value is 5,000. But if you look at our series, the first value isn't 5,000. It's this stupid number here. 5,000 times 1 plus I to the -1. 5,000 times, the I value is 6, so it's going to be 1.06 to the power of -1. Now that whole thing only relates to the A. We've still got a lot more formula to go. I'll just move this over here. Okay. Now, our R value. Our R value is the amount that each new number is getting multiplied by. You can see that this is 5,000 times 1 plus I to the -1. This is 5,000 times 1 plus I to the -2. 5,000 times 1 plus I to the -3. Each one of these is being multiplied by 1 plus I to the -1. So our ratio is going to be 1 plus I. Let's do it. Let's do it in one step. 1 plus I, which is 1.06, to the power of -1. That's our R value. Each term is being multiplied by 1.06 to the power of -1. Now we need to put a second set of brackets here, because then we're going to raise that to the power of n, the number of terms. And there are 1, 2, 3, 4, 5 terms here. And then we're going to subtract 1. Okay, you can see it gets to be a bit of a mess here. But all of this stuff in the square brackets is this bit here. The common ratio, each one is being multiplied by 1.06 to the power of negative 1. That's our common ratio. But then that common ratio needs to be raised to the number of times, and that's 5. The fun doesn't stop there, though, because then we have r minus 1. Now, r is our common ratio, which we've talked about a bit. It's 1.06 to the power of negative 1. And then we need to subtract 1 from that. Oof. Now, good luck typing that into your calculator in one single step. Do it if you feel comfortable with it, but there are going to be brackets everywhere. So the way that I tend to do it is to do this in one step, this in one step, or maybe even 2 steps, and then this, and then I glue it all together. If you do type it all into your calculator in one step, you're going to avoid rounding errors, which is really neat. Okay, I'm going to pause it for a second. I'm going to play with my calculator and come back. Okay, so once I type that in my calculator, I get $21,061.82 approximately. Now, obviously, you can check this on your TVM mode in your calculator. Grab your calculator. Whoops. Okay, so grab your calculator, go into TVM mode. It's going to be compound interest. Make sure it's at the end of each period. That's what it is here. There's 5 years. The interest rate was 6%. We don't know the present value, but we know the payments. They're $5,000 each. The future value is just going to be 0. This question's a bit different to most of the ones you've done, though, because there's only one payment per year, and the compounding period per year is only 1. Click the present value button, and you can see we get negative 21,061, but that's because it wanted me to put in the payments as negative. You get the general idea, though. Now, this is a little more complicated than our past stuff. Just when you're doing this stuff, remember that the A value is not going to be 5,000. You need to adjust it and take it back by 1 plus I to the negative 1. And then the rest of that stuff is going to be this weird ratio here. Practice, practice, practice. Talk to me if you're having trouble with it. There are some little tricks that I haven't put in the video here that I can talk to you about in class. Thank you very much.